go through a couple of the math problems for the percent by mass that is going to be assigned for tomorrow. So you're going to watch, if you want to watch this, you can always skip ahead, look at the different problems and go from there. If you want to watch the whole thing, go for it. That is up to you. Or maybe you do really well by reading the textbook and you can figure it out from there. That is awesome as well. All right. So when we are looking at these percent by mass, we always want to have, we will have like, whenever you're looking at percent, you are always going to have the part on the top and the whole on the bottom, and then you're going to times it by 100, and then that will give you your percent by mass. Okay, so in this problem, we know that this number right here, that's our whole. Okay. Ooh. All right, so that is going to go on the bottom. So our whole compound, whenever you see a whole compound, is going to go always on the bottom. So 78 grams of compound, okay, and 12.4 grams of hydrogen are going to be on the top. Since it's a percent, I'm going to multiply it by 100, all right, and then I am going to do the math. Okay, just plug it into your calculator, and oh my goodness, I'm struggling. 2 point. All right, so we'll get 15.9 for our percent hydrogen. All right, so that is our first part. Okay, that is when you just have one, when you're looking at the one compound or one element in that whole compound. Okay, so if we go to our next problem, it says we have 3.5 grams of, why is this acting up funny? 3.5 grams of X reacts with 10 grams of Y to form compound XY. What is the percent mass of X in the compound? What's the percent mass of Y? Okay, so these are actually both parts. Okay, the 3.5 grams of X and 3.5 grams of Y. So those are both parts. To get the total, we would have to add those together because, again, that's law of conservation of mass. You read that earlier. These are our two reactants. When they form that compound, they're going to have the same mass. So we'll have our 3.5 grams of X plus our 10.5 grams of Y, and that is going to give us 14 grams of XY. So this is our whole part. This is the whole. Okay, so that is going to go on the bottom. So I'm going to put 14.0 grams on the bottom. There's supposed to be a decimal point there. All right, and we want to look at X first. So then we'll put, what is the mass of X? Doesn't want to do decimal points very well on this. Grams of X, so this is XY on the bottom, times it by 100. Okay, so our percent mass of X will end up being 25%. Okay, now you can easily look at it and say, okay, well, there's only two parts to it. So 100% subtract 25%. So this is percent X. That will give us 75% for Y. All right, so these are our two final answers. Okay, our last one is a little bit more challenging. Okay, two unknown compounds are tested. Compound 1 contains 15 grams of hydrogen and 120 grams of oxygen. Compound 2 contains 2% or 2 grams of hydrogen to 32 grams of oxygen. Are the compounds the same? So you want to figure out, first of all, are they the same? When we are looking at this, can we tell? Can we tell right off the bat if we know that the compounds, the percent composition what we would have to do first is to figure out what is the percent composition of them. Okay, so if this is my compound 1, okay, I know hydrogen is 15 grams, oxygen is 120 grams. So total, that's going to give me 135 grams of compound. Okay, so then I'm going to figure out, well, what is the percent that is hydrogen? So 15 grams of hydrogen divided by that whole, so 135 grams of that compound times 100. All right, that is going to give me first the percent that is hydrogen. Okay, so this is about 11.1%. Okay, so then oxygen would be 89.9% oxygen. Okay, compound 2 then. Okay, again, we have hydrogen is 2 grams, oxygen is 32 grams. So a total will be 34 grams of the compound. Okay, so again, we'll take our 2 grams of hydrogen divided by the whole compound. Okay, times 100. And that's going to give me about 5.9% hydrogen. So right now, when we look at this, we know that the compounds are not the same because the percent of hydrogen should be the same in both, and they are not. Okay, it is smaller in compound 2, so there's going to be more oxygen. So these things will not be the same. They will be different. So in a problem like this, you will always need to figure out what is the percent by mass for a compound. You could have just done hydrogen. I figured out what oxygen was a little bit more. I could have done that and I would have realized that it was different amounts. So no, they are not the same.